All right, AP Stat, here's your first binomial example. So if you'll just scroll down through the notes, you will find example 8, which is blood type. Okay, so you're given some information here. Each child has a probability of 0.25 of having blood type O. If there are 5 children, find all of these probabilities. Okay, so the very first part of the problem asks you for the conditions that make this a binomial situation. So obviously, since this is your first example, I'm kind of guiding you as to what kind of distribution this is. So we have to write out our conditions because I'm setting you up for the fact that it is binomial. You need to be aware, though, that on the AP test, if there's a probability problem that involves a binomial distribution, you're going to be expected to figure that out based on whether or not the situation meets the conditions. So keep that in mind as we move through this. Okay, so let's talk about applying the 4 conditions that we talked about in the binomial intro video with this particular situation. So the first thing I'm going to talk about is the fact that there's no reason to consider that these 5 children would not be independent of one another. So we are going to assume that all is well and these children are independent of each other. Okay? And that is kind of something we have to just kind of go on faith with because we're not actually looking at 5 real children. So that's why we're just in our stat bubble, you know. So the children are independent. There are 2 categories. A child either has type O blood or not. So remember, one of your conditions was that there are only 2 categories, success or failure. So please keep in mind that success versus failure here, type O blood would be considered success, not would be considered failure, but we are not using those words in their usual context. Okay, it's not, you're not successful if you have type O blood. It's just for the purposes of the of setting up the problem. Okay, one of the other conditions we have to have is that the probability of success, or in this case, the probability of having type O blood, has to be the same for each observation. So we are told that the probability of a child having type O blood is 0.25, and there's no reason to assume that would change with each child. So that is consistent through the problem. The last condition we have to consider is that there need to be a fixed number of N observations. Notice we are dealing with 5 children. That means those are the only 5 children we're considering. So I'm looking at 5 children at a time, in other words. So this would be considered a binomial situation. And as we do the problems, we're going to use our binomial notation to set this up. So let's look at part B. What is the probability that exactly 3 children will have type O blood? So I do have a binomial situation in which N is 5 and P is 0.25. And I want to know the probability that exactly 3 children have type O blood. This is called a probability statement, and you must show it because you're communicating what you're trying to find. So I am going to go to Staplet, and I am just going to go, this is the home screen of Staplet right here. Under normal distributions and probability, I'm going to choose binomial distributions. I am going to type in a 5 for N because that's how many children I'm looking at. And for the probability they will have type O blood is 0.25. Then if you will come down here and look at this pull down menu here, you have some choices to make. So obviously, since I want the probability X is exactly 3, I'm going to use the default of exactly, and I am going to type in a 3, and then I'm going to click go. Okay, The answer is don't get lost here. The answer is right above the table for mean and standard deviation. So the probability that x equals 3 is 8.79%. So I am going to go back to my notes, 8.79%. Or if you prefer a decimal, you can also do it that way. Doesn't matter to me. Okay, part C. What is the probability all 5 children will have type O blood? So again, I'm going to set up my binomial notation. This is good communication. X equals 5, and then I'm going to go to Staplet again, and I am going to change my value here to 5. Push go. Right above the mean and standard deviation, the probability x equals 5 is 0.1. So that is going to be what I put down here, 0.1% or 0.001. And then part D, what is the probability that all 5 children will not have type O blood? So this is going to be a situation of failure. So success versus failure. So I'm going to write this as binomial 5, and I'm going to use 0.75 here. And then I'm going to go back into Staplet. And now I'm going to have to change P to 0.75, and then I'm going to leave exactly 5 here. Push go. I get 23.73%. Or 0.2373. All right, part E. What is the probability that at least one? Now things are changing a little. And I'm going to look at least one having type O. So I'm switching back over to 0.25 here for my distribution. And I am going to use an inequality this time. If I'm talking about at least one, that means it can't be fewer than one. So that means it's going to be greater than or equal to 1. And then I'm going to use some more communication here to indicate that I know what's happening. So in other words, this is the probability x will equal 1, 2, 3, 4, 5. Okay, all of those. All right, so now I am going to go back to Staplet, and in my probability, I'm going to change that back to 0.25. And now what I'm going to do is down here in my pull down menu, now I have to change it. So if I'm dealing with at least one, I'm going to choose at least one and then put the 1 in, push go. I get 76.27%. So 76.27% or 0.7627. All right, part F. What is the probability that no more than 2 have type O blood? So I'm still dealing with the same parameters here. No more than 2. So the probability that x is less than or equal to 2. It can't be more than 2. So that is why I'm setting this up this way. So this implies that x equals 0 all the way to 2, but not anything more than that. Back to Staplet we go. So now I'm going to use my pull down menu, and rather than choosing at least, I am going to say at most, because it can't be bigger than 2. So I'm going to change the number to 2, push go, and I get 89.65%. Or 0.8965. Okay, part G. What is the probability that at least 4 have type O blood? So same parameters here. The probability that it's at least 4. So that's basically the probability that x equals 4 plus the probability that x equals 5. We're stopping at 5 because n is 5. It's not going to go higher than that. So back to Staplet. I'm going to change my pull down menu here. It's going to be at least. Keep using the wrong keyboard. What's wrong with me? Okay, I get 1.56%. So 1.56% or 0.0156.